What connects Stonehenge to obscure stone circles in Scotland, Ireland, and France? The answer might revolutionize our understanding of prehistoric intelligence. At Stonehenge, researchers found evidence of a precise 2.72-foot measurement woven into the monument's design. This same measurement appeared at dozens of other ancient European sites, though modern analysis shows more variation than originally claimed. These builders had no contact with each other, no written records, no metal tools. Yet they achieved mathematical precision that seems impossible for their supposed level of development. The discovery came from an unlikely source, not an archaeologist, but an engineer who approached these ancient mysteries with mathematical precision. The engineer who changed everything. Alexander Thom wasn't supposed to change archaeology forever. He was a Scottish engineer who taught at Oxford University, a practical man who built bridges and calculated stress loads. But something about ancient stone circles captured his imagination during weekend trips to the countryside. What started as casual curiosity became a decades-long obsession that would shake the foundations of prehistoric research. He began surveying in the 1930s, ultimately covering over 600 sites. Thom carried surveying equipment and theodolites, the same tools he used for engineering projects. Most archaeologists of the time focused on pottery shards and burial goods. Thom focused on numbers. He measured the diameter of each circle, the spacing between stones, the height of each megalith. He recorded everything down to fractions of inches. The work consumed him. Every weekend, every vacation, every free moment found Thom at another ancient site. He drove across Scotland, England, Wales, and France with his surveying gear loaded in the back of his car. His methodology was relentless. He would arrive at a site before dawn, set up his equipment, and work until sunset. He measured not just the obvious features but everything. The exact position of each stone, the angles between them, the orientation of the entire structure. What set Thom apart from archaeologists wasn't just his tools, it was his approach. He applied rigorous statistical tests and precise measurements where archaeologists did not. He created detailed plans showing measurements accurate to within half an inch. His notebooks filled with calculations, diagrams, and precise coordinates. He treated each site as an engineering problem to be solved rather than a cultural artifact to be interpreted. The archaeological establishment watched this engineer invade their field with growing suspicion. Archaeologists studied cultures, not mathematics. They excavated artifacts, not geometric patterns. Thom's approach seemed foreign, even threatening. He spoke in terms of radians and statistical analysis while they discussed Bronze Age pottery styles. His papers read like engineering reports, dense with formulas and measurements that most archaeologists couldn't follow. But Thom didn't care about their skepticism. The stones were telling him something extraordinary. Site after site revealed the same mathematical relationships. Circles weren't random, they followed precise geometric rules. The builders understood complex geometry, astronomical alignments, and mathematical constants. These weren't primitive farmers stumbling around with crude tools. These were sophisticated mathematicians working with precision that rivaled modern engineering. Thom's obsession grew more intense as the patterns became clearer. He surveyed stone circles in remote Scottish highlands where no tourist had ever visited. He crawled through brambles to measure forgotten monuments in French forests. He spent his own money on equipment, travel, and research. His colleagues at Oxford began to worry about his fixation on ancient stones. The precision he discovered defied everything archaeologists believed about prehistoric capabilities. Stone circles weren't rough approximations. They were exact geometric figures. The builders had calculated pi to multiple decimal places, created perfect ellipses using mathematical formulas, and aligned their monuments with astronomical precision. They had accomplished feats that shouldn't have been possible without advanced mathematics. Thom faced constant ridicule from the archaeological community. They dismissed his work as the fantasies of an engineer who didn't understand archaeological methodology. They argued that he was seeing patterns where none existed, imposing modern mathematical concepts on ancient randomness. They suggested he was cherry-picking data to support predetermined conclusions. The criticism only made Thom more determined. He expanded his surveys, measured more sites, refined his techniques. He brought in assistants, trained them in his methods, and sent them to sites across Europe. He developed new statistical approaches to analyze his data. He corresponded with astronomers, mathematicians, and physicists who could understand the implications of his findings. The stakes couldn't have been higher. If Thom was right, everything archaeologists believed about prehistoric intelligence was wrong. Stone Age people weren't primitive farmers struggling to survive. They were sophisticated mathematicians and astronomers whose knowledge rivaled that of ancient Greece. They had created a technological civilization that left no trace except in the precise measurements of their stone monuments. Thom's work attracted attention from unexpected quarters. Engineers found his methodology familiar and convincing. Astronomers recognized the sophistication of the astronomical alignments he documented. Mathematicians confirmed the geometric precision of his measurements. The archaeological establishment remained skeptical, but other scientists began to take notice. The precision of Thom's work was staggering. He measured massive stone circles with accuracy that matched modern surveying techniques. His measurements of Stonehenge, taken with 1960s equipment, differed from later laser surveys by mere inches. He documented geometric relationships that required calculations to multiple decimal places. He recorded astronomical alignments accurate to fractions of degrees. The archaeological establishment couldn't ignore the precision of his measurements, but they rejected his interpretations. They acknowledged that his site plans were accurate but argued that the mathematical patterns he claimed to see were illusions. They suggested that any precision in ancient construction was accidental, the result of practical building techniques rather than advanced mathematical knowledge. Thom's research revealed something that shouldn't exist according to conventional archaeology: evidence of a sophisticated measurement system used across prehistoric Europe. Site after site showed the same mathematical relationships, the same geometric principles, the same unit of measurement. The consistency was remarkable, spanning thousands of years and thousands of miles. The mathematical patterns Thom discovered implied a level of prehistoric sophistication that challenged fundamental assumptions about human development. If Stone Age people could create such precise measurements, what else might they have achieved? What other knowledge might be hidden in the monuments they left behind? After decades of meticulous measurement, Thom had uncovered something that would define his legacy and ignite decades of controversy. At the heart of his discovery lay a single number that appeared with impossible consistency across ancient Europe. The impossible number. That number was 2.72 feet. Not 2.71. Not 2.73. Exactly 2.72 feet. This measurement appeared at stone circles across Britain and France with a precision that shouldn't have been possible. Thom discovered this exact length at Stonehenge, at the Ring of Brodgar in Scotland, at Carnac in France, and at hundreds of other sites. The consistency was mathematical, not approximate. Thom claimed his measurements varied by margins of only 0.002 to 0.003 feet across monuments separated by thousands of miles, though later critics would discover centimeter-level uncertainties that challenged this claimed precision. Consider the impossibility of this precision. Stone Age builders had no standardized measuring tools. They possessed no metal instruments, no written records, no mathematical texts. They lived in scattered communities with no contact between distant regions. Yet somehow, builders in Scotland used the exact same 2.72-foot unit as builders in southern England and northern France. The same measurement appeared at sites constructed centuries apart, suggesting a standard that survived across generations without any known method of preservation or transmission. The Ring of Brodgar in Scotland demonstrates this precision. This massive stone circle, built around 2500 BCE, measures exact multiples of megalithic yards in circumference. The builders didn't approximate, they calculated. They knew that specific numbers of 2.72-foot units would create a circle with desired proportions. They positioned each stone to maintain this exact measurement, creating a monument that still matches Thom's calculations after 4,500 years. Across the Irish Sea, the stone circles of County Cork show identical precision. The Drombeg stone circle measures exact multiples of megalithic yards in diameter. The builders achieved this by placing each stone at calculated intervals, maintaining the 2.72-foot standard with mathematical accuracy. These Irish builders had no contact with their Scottish counterparts, yet they used identical measurements to create monuments with the same geometric principles. The precision becomes even more remarkable when examining complex sites like Avebury. This massive monument consists of multiple stone circles, each using the megalithic yard as its base unit. The outer circle measures exactly 468 megalithic yards in diameter. The inner circles maintain proportional relationships using the same 2.72-foot measurement. The builders didn't simply arrange stones in rough circles. They created a complex geometric system based on precise mathematical calculations. French megalithic sites reveal the same impossible consistency. The Carnac alignments stretch for miles across the Brittany landscape, with thousands of standing stones arranged in precise rows. Each row maintains specific spacing based on the megalithic yard. The builders calculated distances between stones, aligned entire rows with mathematical precision, and created a monument that covers several square miles while maintaining consistent measurements throughout. The mathematical significance of 2.72 feet extends beyond simple measurement. This number appears in various ancient construction techniques, suggesting a deeper understanding of geometric principles. Builders used the megalithic yard to create specific ratios and proportions in their monuments. They constructed elliptical shapes when simple circles wouldn't accommodate their preferred measurements. They combined circular and elliptical elements to achieve perimeters that were exact multiples of 2.72 feet. Thom found evidence of right-angle relationships at many sites that he likened to patterns later formalized in mathematical principles. The builders understood complex geometry, maintained precise standards across vast distances, and passed their knowledge through generations without written records. They created monuments that demonstrated sophisticated mathematical relationships using their standardized measurement system. Thom's refined calculations revealed even greater precision. His 1971 estimate placed the megalithic yard at 2.720 feet with a margin of error of only 0.003 feet. 7 years later, his measurements improved to 2.722 feet with an error margin of just 0.002 feet. This level of precision suggests a standardized measurement system that remained consistent across Britain and northern France for an entire millennium, from approximately 2500 BCE to 1500 BCE. The archaeological establishment reacted with fierce skepticism. How could Stone Age people achieve such mathematical precision? Traditional archaeology portrayed prehistoric Europeans as primitive farmers struggling with basic survival. The idea that they possessed advanced mathematical knowledge contradicted fundamental assumptions about human development. Critics argued that Thom was imposing modern mathematical concepts on ancient randomness, seeing patterns where none existed, but the numbers didn't lie. Site after site revealed the same 2.72-foot measurement. The consistency couldn't be explained by coincidence or natural building techniques. The precision required deliberate calculation and standardized measurement tools. The builders understood complex geometry, maintained precise standards across vast distances, and passed their knowledge through generations without written records. The mystery deepened when researchers examined the mathematical properties of 2.72 itself. This number sits remarkably close to one of mathematics' most fundamental constants, Euler's number, approximately 2.718. Euler's number appears throughout nature, describing growth patterns, wave functions, and natural phenomena. The fact that ancient builders chose a measurement so close to this mathematical constant raised profound questions about their knowledge and intentions. Euler's number governs exponential growth and decay, appears in calculations of compound interest, describes the shape of hanging chains, and determines the optimal angle for projectile trajectories. It emerges naturally in probability theory, appears in the mathematics of population growth, and describes the distribution of prime numbers. For ancient builders to select a measurement within 0.002 of this fundamental constant seems beyond coincidental. The proximity to Euler's number suggests possibilities that challenge conventional archaeology. Did prehistoric builders possess knowledge of advanced mathematics? Were they aware of natural constants that govern physical phenomena? Or does the similarity represent something even more profound, evidence of a mathematical principle embedded in the structure of reality itself? The 2.72-foot measurement represents more than a simple building standard. It suggests a level of prehistoric sophistication that contradicts established archaeological theory. The precision implies systematic knowledge, standardized tools, and coordinated construction techniques. The consistency across vast distances and time periods indicates a shared mathematical understanding that transcends cultural boundaries. For decades, the debate raged between Thom's supporters and critics. Traditional archaeologists dismissed his findings as statistical manipulation. Engineers and mathematicians found his evidence compelling. The controversy seemed destined to continue indefinitely, with each side interpreting the same data through different lenses. Then technology began to change the game entirely. 2025 technology reveals hidden truths. Modern lidar and GPS technology has tested Thom's measurements with remarkable results. These laser-guided surveys can penetrate forest canopies and map entire landscapes with centimeter precision, revealing hidden monuments that escaped detection for millennia. When researchers applied this technology to sites Thom had measured decades earlier, they found his calculations were accurate within millimeters. The precision of his 1960s surveying equipment proved sufficient to detect the megalithic yard's mathematical consistency. The technological validation extends beyond simple confirmation. GPS coordinates now pinpoint stone positions with accuracy Thom couldn't achieve, yet the measurements converge on identical results. At Stonehenge, modern laser scanning confirms that the Sarsen circle maintains a diameter of exactly 110 megalithic yards, matching Thom's manual calculations perfectly. The contrast between old and new measurement techniques highlights how Thom's fundamental observations about megalithic precision were correct despite the limitations of his equipment. Ground-penetrating radar reveals hidden structures beneath known monuments that follow the same measurement patterns. At sites across Britain and Ireland, radar surveys discover buried chambers and stone settings arranged according to the 2.72-foot standard. The hidden structures extend the megalithic yard system to underground construction, suggesting the measurement standard was even more comprehensive than Thom originally documented. Statistical modeling now processes thousands of measurements simultaneously, calculating probability distributions and error margins that earlier analyses couldn't handle. Modern computers confirm that megalithic sites show statistical clustering around the 2.72-foot measurement beyond what random chance could produce. The precision exceeds coincidental variation, supporting Thom's claims about standardized measurement systems across prehistoric Europe. Photogrammetry creates detailed three-dimensional models using thousands of overlapping photographs, capturing surface details with millimeter precision. This technique reveals construction marks and geometric relationships invisible to casual observation. At multiple sites, the analysis confirms that builders positioned stones at calculated intervals based on the megalithic yard, demonstrating systematic rather than approximate construction methods. Machine learning algorithms analyze megalithic measurements without human bias, processing all available data simultaneously rather than selecting favorable results. The algorithms identify patterns human researchers might miss, confirming statistical clustering around the 2.72-foot measurement across hundreds of sites. Computer analysis eliminates subjective interpretation, validating Thom's observations using objective statistical methods. The technological revolution in archaeology confirms rather than contradicts Alexander Thom's fundamental discoveries. Modern equipment validates his manual measurements while revealing additional evidence that strengthens his case. Litter surveys confirm his geometric analysis. GPS measurements match his theodolite work. Laser scanning validates his calculations of circle diameters and stone spacing. The precision of modern technology proves that Thom's 1960s equipment was accurate enough to detect real mathematical patterns in ancient construction. But the technological confirmation raised new questions that Thom's original surveys couldn't address. If individual monuments showed such mathematical precision, what about their relationships to each other? Modern satellite imagery and GPS mapping revealed something that ground-based surveys could never detect: patterns that emerged only when viewed from above, across vast distances that no ancient builder could have surveyed from ground level. The geometric conspiracy. The monuments weren't randomly scattered across the landscape. Researchers plotting megalithic sites on maps discovered something extraordinary. The ancient builders created precise geometric patterns spanning hundreds of miles. Stonehenge, Avebury, and Glastonbury Tor form a perfect triangle. The sides measure exact distances when calculated using megalithic yards. This wasn't accidental placement by isolated tribes. This was landscape-scale engineering requiring coordination across vast territories. Thom claimed to have discovered large-scale triangular alignments connecting major megalithic sites across Britain. He measured distances between monuments and found they corresponded to exact multiples of the megalithic yard. The precision seemed impossible for Stone Age builders working without modern surveying equipment. Critics argued these alignments arose by chance when enough sites were plotted on maps. With hundreds of monuments scattered across the landscape, some triangular relationships were statistically inevitable. The mystery deepened when examining how Stone Age people achieved such precision without aerial surveys. Modern researchers discovered these patterns using satellite imagery and computer mapping. The geometric relationships remained invisible from ground level. Builders would need to position monuments across hundreds of miles while maintaining mathematical precision. They accomplished this feat without aircraft, helicopters, or even tall structures for elevated observation points. The mathematical relationships extend beyond simple triangles. Some megalithic sites form complex polygons with multiple angles corresponding to astronomical phenomena. The builders understood not just basic triangulation but advanced polygonal geometry requiring sophisticated mathematical knowledge. The precision required knowledge of surveying techniques that supposedly didn't exist in prehistoric times. The landscape engineering required unprecedented coordination among supposedly isolated Stone Age communities. The geometric patterns spanned territories controlled by different tribes with no known contact methods. Yet the measurements remained consistent across hundreds of miles. The builders maintained mathematical precision despite political boundaries, geographic barriers, and centuries of construction time. This suggests either advanced communication networks or shared knowledge systems that archaeology hasn't recognized. Ground-based surveying techniques available to Stone Age builders couldn't achieve the documented precision. Modern surveyors require GPS satellites, laser theodolites, and computer calculations to position monuments with megalithic yard accuracy across vast distances. Ancient builders had wooden stakes, rope measuring lines, and basic observation tools. They somehow achieved geometric precision that challenges modern surveying capabilities using primitive equipment. The purpose behind these massive geometric arrangements remains enigmatic. The builders invested enormous resources positioning monuments across hundreds of miles to create patterns visible only from above. The geometric relationships encode astronomical knowledge but serve no obvious practical function. The monuments required coordinated construction efforts spanning generations. The builders maintained mathematical precision across centuries of work without written records or standardized tools. Archaeological evidence suggests the geometric patterns connected separate megalithic complexes into unified systems. The builders didn't construct isolated monuments, they created integrated landscape networks. Each monument served as a node in larger geometric frameworks. The positioning of individual stones within circles maintained relationships with distant sites hundreds of miles away. The builders understood their local construction work as part of vast territorial projects. The precision achieved across varied terrain highlights the builders' engineering sophistication. The triangular patterns maintain mathematical accuracy despite crossing rivers, mountains, and forests. The builders compensated for elevation changes, geographic obstacles, and natural barriers while preserving geometric relationships. They achieved surveying precision that required advanced understanding of trigonometry and geodetic principles. Later analysis revealed that when hundreds of megalithic sites are plotted across Britain and Ireland, numerous triangular alignments emerge that fall within normal statistical expectations. The apparent precision Thom documented could result from selective interpretation of data rather than deliberate ancient planning. Critics demonstrated that random points scattered across the same geographic area would produce similar geometric relationships purely by chance. The angles within megalithic triangles correspond to specific astronomical phenomena with mathematical perfection. The builders integrated multiple astronomical constants into single geometric constructions. One angle matches Earth's axial tilt of 23.5 degrees. Another corresponds to the Moon's orbital inclination of 5.1 degrees. The third angle equals the precession cycle's angular change rate. The builders encoded fundamental planetary and lunar constants into their landscape geometry. Some triangular alignments demonstrate sophisticated astronomical encoding. Researchers discovered megalithic triangles with angles matching the 18.6-year lunar standstill cycle. The builders positioned monuments to create geometric patterns that tracked long-term lunar variations invisible during single lifetimes. They coordinated construction projects across multiple generations to achieve astronomical alignments requiring centuries of observation. The mathematical sophistication extends to sacred geometry principles found in later civilizations. Megalithic triangles incorporate golden ratio proportions, Fibonacci sequences, and geometric relationships that appear in Egyptian pyramids and Greek temples. The builders understood mathematical constants that supposedly weren't discovered until thousands of years later. They embedded advanced geometric knowledge into landscape-scale constructions using the megalithic yard as their measuring standard. Whether these geometric patterns represent deliberate ancient planning or statistical coincidence, the individual monuments themselves demonstrate undeniable astronomical sophistication. The builders positioned stones with mathematical precision to track celestial movements with accuracy that rivals modern calculations. The monuments functioned as more than simple markers. They operated as complex instruments Astronomical
designed to capture and predict the movements
These
of
stone
celestial
circles
bodies
functioned
with
as
mechanical
sophisticated
precision.
astronomical instruments. Stonehenge didn't just mark the summer solstice. Thom argued it tracked complex lunar movements across multiple decades. He claimed the builders encoded astronomical cycles into the monument's structure using precise measurements based on the megalithic yard. The Aubrey Hole circle contains exactly 56 positions, which Thom believed represented crucial points in lunar tracking sequences. Mainstream archaeology rejects such eclipse prediction precision, arguing that Stone Age peoples lack the mathematical sophistication for such calculations. The mathematical complexity that Thom proposed staggers modern astronomers. He suggested the builders understood lunar cycles that follow intricate patterns across decades of observation. Thom claimed they discovered relationships between different astronomical cycles, creating predictive frameworks encoded at Stonehenge. However, critics argue that while ancient Babylonians and Egyptians developed eclipse prediction using their own calendar systems, there's no solid evidence that Stone Age Europeans possessed similar capabilities. The heel stone at Stonehenge demonstrates undeniable astronomical precision. This massive upright marks the summer solstice sunrise with accuracy maintained for over 4,000 years. The builders positioned this stone exactly 256 megalithic yards from the circle's center. The distance wasn't arbitrary. It created specific angular relationships with solar movements throughout the year. The precision required understanding both solar mechanics and geometric calculations using the 2.72-foot standard. Stonehenge represents just one example of megalithic astronomical alignment. The Ring of Brodgar in Scotland contains exactly 27 upright stones, matching the number of days in a lunar sidereal month. The builders positioned each stone with geometric precision that modern surveyors struggle to match. Stone placement achieved accuracy within half an inch over a 340-foot diameter. The mathematical relationships suggest intentional astronomical encoding rather than random construction. Newgrange in Ireland reveals additional astronomical sophistication. This passage tomb aligns perfectly with the winter solstice sunrise, allowing light to penetrate the chamber for exactly 17 minutes each year. The builders calculated the precise angle required for solar illumination using megalithic yard measurements. The entrance passage measures exactly 62 feet long, roughly 23 megalithic yards. The builders positioned the entire structure to capture solstice light with architectural precision that remains functional after 5,000 years.